Solve each quadratic equation by completing the square. Give the exact answers and decimal approximations rounded to 2 decimal places. Check the answers in the original equation. Alright, so to solve by completing the square has a few different steps. Notice we cannot immediately apply the square root property because we do not have just a quantity square. So actually our goal is to create an equation with a quantity squared. So to do this, first we put all variable terms on one side. Alright, we've got that. Second, is the lead coefficient equal to 1? If not, divide through entire equation by that lead coefficient. So notice we already have that so far. We have x squared plus 6x equals 18. We have all the variable terms on one side, and our lead coefficient is 1. Alright, so now what we do is we take half of the b coefficient. So we find half of the b coefficient and square it. Add that value to both sides. Alright, so in this case our b coefficient is 6. So I'm going to find half of 6 is 3, and I'm going to square it. 3 squared is 9. So I'm going to add 9 to both sides of the equation, yielding x squared plus 6x plus 9 is equal to 27. Fourth, factor, in this case the left side, as a perfect square. So if you've done steps 1 through 3 correctly, we now have a perfect square trinomial on the left. X squared plus 6x plus 9 is x plus 3 squared. And so now we have that squared quantity on one side, and we can apply the square root property. So then x plus 3 is plus or minus square root of 27. And now we break that up into two equations. X plus 3 is negative square root 27. X plus 3, I should mention here, 27 is 9 times 3, so square root of 9 times square root of 3, which is 3 times the square root of 3. We do want to simplify those radicals. So then x plus 3 is negative 3 root 3, or x plus 3 is positive 3 root 3. And now we'll solve for x, or isolate x, by subtracting 3 from both sides. Remember that that is not a like term with the 3 root 3. So x is equal to negative 3 minus 3 times the square root of 3, or x is negative 3 plus 3 times the square root of 3. Now those are exact values, but like before, we can approximate them. So let's see, negative 3 subtract 3 times the square root of 3 gives me approximately negative 8.20. And negative 3 plus 3 times the square root of 3 is approximately 2.20. Let's check our work. First with negative 8.20. Negative 8.20 square plus 6 times negative 8.20. Is this equal to or approximately equal to 18, since we did approximate. So let's see, negative 8.20 square is negative 67, no, it's positive 67, sorry about that. 67.24. And let's see, plus 6 times negative 8.20. That's minus 49.2. 67.24 minus 49.2 is 18.04, which is approximately 18. So that checks out. And now the other solution. 2.20 square plus 6 times 2.20. Is this equal to 18? Well, 2.2 square is 4.84, and 6 multiplied by 2.2 is 13.2. And let's see, 4.84 plus 13.2 is 18.04. which is approximately 18, and so that checks out as well, and we are confident in our solutions. Alright, example B, we have x squared minus 4x is equal to 12. Notice again we have everything with the variable on one side, and our lead coefficient is 1, so we can go straight to that third step. The b value is negative 4, so as we did before, we find half of that. Half of negative 4 is negative 2, and negative 2 squared is positive 4. So we will add 4 to both sides of the equation. X squared minus 4x plus 4 is 16. The left-hand side factors as x minus 2 squared. Applying the square root property, x minus 2 is positive or negative square root of 16. So then x minus 2 is positive or negative 4. So then x minus 2 is negative 4, or x minus 2 is positive 4, and we'll solve for x by adding 2 to both sides of each equation. So x is negative 2, or x is 6. Let's check our work, first with negative 2. Negative 2 squared minus 4 by negative 2, is this equal to 12? So that's 4 plus 8, which is 12. That checks out. Checking the positive solution, we'd have 6 squared minus 4 times 6, is this equal to 12? So that's 36 minus 24, which is 12. That checks out, and we're confident in our solutions. Example C, we have x squared plus 10x plus 3 is equal to 0. Alright, so notice we need to get rid of that 3 to put it in the form we want. So I will subtract 3 from both sides, which gives us x squared plus 10x is equal to negative 3. Alright, now I will complete the square. My b coefficient is 10. Half of 10 is 5. And 5 squared is 25. So I will add 25 to both sides of the equation. So x squared plus 10x plus 25 is 22. X squared plus 10x plus 25 is x plus 5 squared. Applying the square root property, x plus 5 is plus or minus the square root of 22. Square root of 22 can't be simplified, so then we just break this up into two equations. X plus 5 is negative square root of 22. X plus 5 is positive square root of 22. and I'll subtract 5 from both sides to isolate the x. So then x is negative 5 minus the square root of 22. X is negative 5 plus the square root of 22. Go ahead and find some approximate values for these. So negative 5 minus the square root of 22 is approximately negative 9.69. And negative 5 plus the square root of 22 is approximately negative 0.31. Right, let's check those. First, the negative solution. I'm sorry, they're both negative. Negative 9.69 first. Negative 9.69 square plus 10 by negative 9.69 plus 3, is this equal to 0? Negative 9.69 square that's 93.8961. 10 times negative 9.69 would be, what, negative 96.9 plus 3. 93.8961 minus 96.9 plus 3, going through that arithmetic, is negative 0.0039, which is pretty close to 0. So that checks out. And now the other solution. Negative 0.31 square plus 10 times negative 0.31 plus 3, is this equal to 0? Alright, so negative 0.31 square is 0.0961 plus 10 times negative 0.31, that would be minus 3.1 plus 3. I guess I don't need that yet. 0.0961 minus 3.1 plus 3 is negative 0.0039 as well. And so that is approximately 0, which checks out as well, and I am confident in my solutions to the equation.